This V4 is not connected to any other edges, therefore this is an example for an isolated vertex. If the degree of the vertex is 1, then it is called as a pendant vertex. A graph containing n vertices and no edges is called a null graph. That's it. A vertex having no incident edge is called an isolated vertex. Hello dear students, welcome to this session of Discrete Mathematics class. I am Mr. Niranjan, Faculty Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence. In my previous class, we have discussed regarding definition of a graph and different types of graphs and the examples. Now, let us come to a few more types of graphs in this graph theory. Let us recall what is a graph. A graph is a collection of points called vertices, and the collection of lines is called as the edges, of which joins either in pair or vertex by or a single vertex. So, in general, a graph is nothing but a collection of vertices and collection of the edges. So, a graph is nothing but an ordered pair and which is represented as G. A graph G is equal to V comma E, where V is the number of vertex and E is the number of edges. Right. Now, let us write for example, let us consider this is an example for a graph. So, these are the vertices, vertex. So, let us represent this as V1, V2, V3 and V4. So, these are called the vertex. So, there are 4 vertex. And how many edges are there? Let us represent this as E1, E2, E3 and E4. These are called the edges. So, there are 4 edges. So, here this contains 4 vertex and 4 edges. So, therefore, this is denoted as G is equal to V comma E. That is V comma E is nothing but vertex and the edges. So, a graph is an ordered pair. This is an ordered pair which is denoted as V comma A, which contains number of vertex and the number of edges. So, where V is a non-empty set of vertices and E is a non-empty set of edges. So, this is what we have studied in our previous class. Now, let us come to the next concept. What is the degree of the vertex? So, the degree of the vertex is also called as the valency of the graph. So, the degree of vertex, or it is also called as the valency. So, the degree of a vertex is the number of edges incident on a vertex. The number of edges which incident on a vertex with the self loop is counted twice, and the degree of a vertex is denoted as DEG, degree of V1, or D of V, degree of V. So, a degree is nothing but the number of edges incident on a vertex with the self loop is considered as twice. Now, let us take an example. For example, let us write a simple graph. Now, let us represent this as V1, V2, V3 and V4, and this is V5. Right. Now, here, so according to the definition, the degree of the vertex is the number of edges incident on a vertex with the self loop is counted twice. Now, let us write one self loop here for this. Okay. Now, this is E1, E2, E3 and E4. Now, let us write down the degree of this. So, degree of V1. So, V1 is connected one time plus one time plus one time. 1 plus 1 plus 1, that is equal to degree of V1 is equal to 3 here. Right. So, similarly, degree of V2. So, for V2 there is no edge. So, therefore, degree of V2 is equal to 1. Similarly, degree of V3. Degree of V3, there is no edge, that is also equal to 1, and degree of V4. So, degree of V4 is equal to, this is 1 edge plus a self loop is there. According to the definition, a vertex with the self loop is counted twice. So, this is 1 plus 2, that's equal to 3. So, the degree of V4 is equal to 3. Whereas, if you come to the point V5 here, so there is no edge at all. So, edges incident on a vertex. So, there is no edge at all. So, therefore, the degree of V5 is equal to 0. Here there is no edge at all. Therefore, the degree is equal to 0. This is an example for the degree of a vertex, or it is also called as the valency. So, consider a simple graph V1, V2, V3, V4, and E1, E2, E3 and E4, this is a self loop. The degree of E1 is equal to how many edges are incident on this vertex? V1 to V2, V1 to V3 and V1 to V4. Therefore, 1 plus 1 plus 1 is 3. The degree of V1 is 3. Again from V1 to V3 it is, so that is V2. There is no edge, therefore V2, the degree of V2 is 1. Similarly, the degree of V3 is 1. Whereas if you come to the V4, we have one vertex and one self loop. Therefore, the degree of V4 is equal to 1 plus 2, that's equal to 4. And whereas the degree of V5, here this vertex does not have any incident edge. There is no edge at all. So, therefore, the degree of this V5 is equal to 0. This is an example for the degree of a vertex. Let me take one more example. So, here no edges are incident on this vertex, so therefore the degree is equal to 0. Let me take one more example. Let us write V1, V2, V3, V4. Let us draw a line, okay, then V4, V5, V6, V7, V7, okay, and write one more V8. Now, see, let us consider how many, what is the degree of V1, V2, V3. Now, here the degree of V1 is equal to, so according to the definition, the number of edges incident on the vertex. Let us represent this is E1, E2, right, E3, E4, E5, E6, E7, right. Now, let us see how many, what is the degree of V1? So, for V1, 1 plus 1, that is the degree of V1 is 1. And degree of V2 is also 2. The degree of V2 is also 2. Whereas the degree of V3 is 1, 2 and 3. Degree of V3 is equal to 3, right. So, if you come to degree of V4, what is the degree of V4? 1 and 2. So, the degree of V4 is equal to 2. Similarly, if you write the degree of V5, degree of the vertex 5 is 1 and 2, 2 degree, valence is 2. Degree of V6 is 1 and 2, that is 2. So, if you observe carefully, the degree of V6 is 2 and the degree of V7 is equal to 1 and V8 is an isolated, the degree of V8 is equal to 0, that's all. This is how we are going to write the degree. Suppose if I put a self loop here, then the degree we are going to get, if you put self loop say anywhere, suppose if I put a loop here like this, that's equal to, let us call it as E8, then the degree of V1, for this degree of V1 is equal to 1 plus 2, 2 plus 2, that's equal to 4 we will get. If a loop is considered as, according to the definition, self loop is counted as a twice. So, this vertex V1 has 2 degree plus this self loop has 2 degree. So, therefore, the degree of this V1 including the self loop is 2 plus 2 is equal to 4. That's it. Now, let us come to the next concept, isolated graph, isolated vertex. Now, from the previous itself we can see this is an example for a isolated. Here it is an isolated. V5 is isolated. Here this is also an isolated. So, what is an isolated here? A vertex having no incident edge is called an isolated vertex. A vertex having no incident edge. A vertex having no incident edge is called an isolated. Isolated. You know the meaning of isolated? So, a vertex having no incident edge is called an isolated vertex. That is, a vertex having no incident edge, that is 0, is called an, so a vertex having no incident edge is called an isolated vertex, or it can also be defined as, let us take an example. So, that means a vertex having no incident edge. Let us consider this graph. This is V1, V2 and V3. So, E1, E2, E3, another point, this one V4. Now, here, so V1, V2, V3 have incident edges, whereas if you come to V4, so here V4 does not have any incident edge, therefore V4 is an isolated vertex. This is an isolated vertex. That's all, okay. So this is not connected to any other edges. This V4 is not connected to any other edges. Therefore, this is an example for a isolated vertex. Just if it is not connected to any vertex, then it is called an isolated vertex. That's it. Now let us come to the next one, pendant vertex. So pendant vertex, a vertex having the degree 1 is called as the pendant vertex. So if the degree of the vertex is 1, then it is called as a pendant vertex. So if the degree here, if it is 0, then it is called an isolated vertex. Here if the degree is equal to 1, it is called as a pendant vertex, right? Now let us take an example, same example. Let us consider here this is V1, V2 and V3, the edges E1, E2 and E3 and this point V4. So here the degree of V1, V2 and V3 can be written as the degree of V1 is 2 and the degree of V2 is 2 and the degree of V3 is also equal to 2, whereas the degree of V4 is equal to 1. Here not connected to any vertex. So the degree is equal to 1. Therefore, this is an example for a pendant vertex. That's it. Okay. A vertex having degree 1 is called as the pendant vertex. If the degree of the vertex is 1, then it is called as a pendant vertex. This is an example for a pendant vertex. It is the degree of V4 is equal to 1. So therefore, this is a pendant vertex. Now let us come to the next one, null graph. Null graph. Null means if every of a graph is isolated, then it is called as a null graph. So if it is isolated, then it is called as a null graph. Okay. Every graph which is isolated, then it is called a null graph. Or it can also be defined as a graph containing n vertices and no edges is called a null graph. That's it. That is a graph containing n vertices. If the number of vertices are there but no edges, then it is called a null graph. Let us consider for example, this is also an example for a null graph. There are n vertices. These are all vertices. V1, V2, V3, V4 vertices, but there is no edges. This is an example for a null graph. Another graph, let us consider, this is also an example for a null graph. V1, V2, V3 and V4. There are 4 vertex but no edges. Such a graph is called as a null graph. That means a graph contains n number of vertices but no edges is called a null graph. That is isolated, then it is called as a null graph. So it contains number of vertices but no edges, then such a graph is called a null graph. That is called as a null graph, right? Suppose if a graph having only one vertex but no edge, such a graph is called as a trivial graph. That's it. Okay. That is, so a graph having only one vertex, no edge is called a trivial graph. Trivial graph means a graph having only one vertex but no edges, only one vertex and no edges is called a trivial graph. So this is an example for a trivial graph. So if a graph containing n number of vertex but no edges is called a null graph. This is the difference between the null graph and a trivial graph. Okay, hope you got an idea, right? Now let us come to the next concept, even and odd vertices. Even, so you know even and odd, 2, 4, 6 are even, odd 1, 3, 5, 7, they are all called as the odd numbers. So here also a vertex is called an even vertex if its edges are even. If the number of edges are even, then the graph is called as an even graph. If the number of vertex is odd, is called as an odd graph. That is called, the vertex is called an odd vertex if its degree is odd. That means the vertex is called an even vertex if the degree is even. The graph contains even number of degree of vertex, then it is called an even graph. A graph contains odd number of vertex, then it is called an odd graph. That is even and odd vertices. Here a vertex having even number of vertices is called an even vertex, even degree is even. If the vertex is called an odd vertex if its degree is an odd. Now let us take an example for even and odd. Now let us take a very simple example for even is, this is V1, V2 and V3. So the edges are E1, E2 and E3. Write down the degree of V1. Here the degree of V1 is 1 and 1, that is 2. Degree of V2 is this vertex have 2 edges, that is 2, and the degree of V3, this vertex also have 2 edges, that is equal to. So this is an example for a even graph, right? This is an even graph. Okay, now let us take an example for an odd graph. So suppose if I write like this: V1, V2, V3, V4. So this is V5, another one is V6. Here the edges are E1, E2, E3, E4, E5 and E6. Now let us come to this. The degree of V2. Here what is the degree of V2? V2 is equal to 1, 2 and 3. This is 3. The degree 3 vertex. There is E5, E1 and E2 are the 3 edges here. So the degree of V2 is 5. Similarly, what is the degree of V4? The degree of V4 is 1, 2 and 3. And if we consider the degree of V5, the degree of V5 is equal to 1. So this is an example for an odd graph. This is an odd graph, and whereas this is an even graph. Okay. Now, so a graph containing a graph which is called an even graph if the vertex, if it contains even number of vertices, vertex. A graph is called an odd graph if it contains odd number of vertex. That's it. Okay. Hope you got an idea regarding even and odd graph. Let us come to the next concept: directed graph. Directed graph. So what is a directed graph? A directed graph G is equal to V comma E consists of the vertices V and the set of direct edges. So a graph consisting of direct vertex and the set of edges is called as a direct graph. A directed edges associated with the ordered pairs V1 and V2 is to start at V1 and end at V2. Okay. Now let us take an example for this directed graph. Now let me take one example. So here let us consider this V1, V2, V3 and V4, right? Now let us write the loops for this. This is one loop, another one is, this is another loop. Now let us write the edges. So this is E1, then E2, E3, E4, then this is, let us call it as E5 and E6, right? Now according to the definition, a directed graph consisting of vertices V and the set of edges C. A direct edge is associated with the ordered pairs V1 comma V2 is to start with V1 and end at V2. So see here this, let us give the direction for this. So this one V1, this started at V1 and end at V2. This is C, this is the direction. Okay. And similarly this V4, this start with V4 and ends at V2. So this is called an example for a directed graph. See here the graph start at the point, the starting point is V1 and ends at V2. Similarly this V4 starts at the point V4 and ends at V2. So this is an example for a directed graph, right? Similarly if I consider this point starts at V4 and ends at V2. So this is an example for a directed graph. So that means it will starts at V1 and ends at V2. This is an example for a directed graph. Now let us come to the next concept, subgraph. So we have already studied in our previous class regarding subsets. Now the same concept we are applying for the subgraphs also. A subgraph of the graph G is equal to V comma is a graph if H is equal to W comma F is a graph, that is such that F is a subset of V and F is a subset of E. See here this G is equal to V comma E. So here the subgraph of this graph V comma E is H comma H, that is H is equal to W comma F, where this W is the subset of P, W is the subset of V and F is the subset of E. That's it. If W is a subset of P and F is a subset of E, then such a graph is called as the subgraph. So listen to me, I will explain once again. A subgraph of this V comma E is a graph if h is equal to w comma f is a graph. So this h is equal to w comma f is called the subgraph of v comma e if h is a graph. So such that w is a subset of v and f is the subset of e, right. Now let us take an example for subgraph. Let me explain this in detail by taking an example. Now let us write this an example. V1, V2, V3, V4, V5, okay, and write on the edges. Edges are here, it is E1, E2, E3, then E4, E5, E6, E6, and this one E7. Okay, even this also E8, right, E8. Now the subgraph of this is the graph, then the subgraph of this is denoted as, if I take this, that is V5, V1, V2 and V3. This is the subgraph of the given graph, that's it, okay. That is E6, E5, E4 and this one E2. So therefore this is the subgraph of this graph, that's it, okay. This is how we are going to write the subgraph. That means if this graph is contained in this graph, then this is called the subgraph, that is the meaning. So a subgraph of the graph G is equal to V comma is a graph if H is equal to W comma F is a graph. So if this is a graph, then this is called the subgraph of this, just like as that of the subset, that's it. So that's regarding the subgraph. So hope you got an idea regarding the subgraphs. So that's all regarding today's session. Let us meet with different concepts in the next session. Thank you very much.